Hey there, ProbStat students. This is Mr. Mitchell. We're going to start into our new chapter of probability, part of the name of our course. So we're going to be dealing with probability for the next several chapters. We've been really working at statistics for the most part, the beginning part of the year. Now we're going to transition into probability, and then we kind of switch back to statistics a little later, and they kind of fluctuate back and forth after we deal strictly with probability here for a while. Okay, so we're going to take a look and go through some things. So what is probability? All right, what is probability? Let me get myself out of the way here so you can see. There we go. Probability is the likelihood of an event. All right, it's an actual numeric value. All right, it's not just, well, I think this is, it's not very likely or it's very likely. It gives a number to it. Okay, can be anything between 0 and 1, including. So the probability that you are in school today is 0. You are not in school today. There's no chance that that is going to happen. You are at home. Okay, and the probability that I am in my classroom right now recording this video is 1. You can see the background behind me. I am sitting in my chair at my desk recording the video. Okay, everything else can be in between there. Those are definite probabilities of 0 and 1. What's the probability it's going to rain? What's the probability that you get a flat tire? That's not very likely that you get a flat tire, but it can happen. What's the probability it's going to rain? Well, it depends on what the weather is calling for and what it just looks like outside. If the sun is shining and there's not a cloud in the sky, it's not very likely that it's going to rain, but it could happen. If it's very, very cloudy and gloomy, then it changes the probability, if that makes sense. Okay? So events with probabilities close to 1 or more likely of it. Events with probability close to 1 or more likely to occur. Okay? So maybe there's no clouds in the sky or very few, it's very sunny. It's not very likely to rain, but it still could happen. Okay? Or it looks very gloomy and they're calling for rain. It just hasn't rained yet, so there's a very, very good chance that it's going to rain. That's kind of the two comparisons there. Close to 0 or close to 1. All right? All right, the way we write this, so we're always in math about writing less. P parenthesis A parenthesis means the probability of A. That's the way we say that. That's the way we write it, so we don't have to write the word probability of A out over and over and over again. Okay? So there's 3 ways to find probability. Intuition is just kind of like we have a feel for it. We don't usually give a number to it. If we do, it's just a made-up number. We don't really, so intuition. Relative frequency, we count up how many things there are and put that number on the bottom, and then we count up how many things could have us win. We put that on the top. Okay? And then equally likely outcomes is another method that we'll look at. Okay? The intuition method. It's just based on how we feel. Okay? I'm 95% sure that I will attend the party. You're not 100% sure because you're not at the party yet, right? Something could happen that would prevent you from going to the party. You could get sick. You could get a flat tire. There's a lot of things that could prevent you from being 100% sure that you'll be at the party. Okay, you can be 99.9% sure, but until you actually walk through the door, something could happen, okay? So that's just the intuition. You're putting a number based on the way you feel. It has no bearing. What's the difference between I'm 95% sure and I'm 93% sure? No, there's no difference. It's the same thing. Okay. So just keep that in mind. This is kind of a feel for it, but that number really doesn't mean exactly anything. I don't think there's any difference between an 80% and a 95%. When you get into like 50%, okay, now that's a bigger difference because you're like on the fence. Okay. All right. Probability is a relative frequency. This is something that we do use. So the first method, we really don't use it a whole heck of a lot. So we make a fraction. F is the frequency of an event. N is the sample size. So N is everything that could happen. F is the number of ways you could possibly win. So let's just say There's 20 kids in a class. Let's make it easier. Let's make it 10. There's 10 kids in class, and everybody puts their name in a hat. So 10 goes on the bottom because we're going to put everybody's name in the hat. How many ways can you win? 1. So that's 1 out of 10. So that's a relative frequency. You count up the number of ways total on the bottom, the number of ways you can win on the top. It doesn't always have to be winning, but that's just an example that I think makes more sense to us. Okay. Example, if you note that 47 of the last 100 applicants for a job have been female, the probability the next applicant would be female is 47 over 100, 0.47. So that's the probability. That's a relative frequency. If we follow suit, okay. So the law of large numbers, in the long run, as the sample size increases and increases, the relative frequencies of outcomes gets closer and closer to the theoretical or actual probability. Example of that is tossing a coin. I'm going to write down a coin here. If you toss a coin millions and millions and millions of times, you should get half heads and half tails. If you toss a coin 3 times, you can get all heads and no tails. 3 is not a very large number. 10 trillion is a lot. So if you toss a coin over and over and over and over and over again, it should be half. Okay. If you do it 3 times or even 4 times or twice, you can get all of one and none of the other. It doesn't have to be 50-50. Okay. So just keep that in mind. The law of large numbers, how that plays a role in what we do. Anything can happen on one game or on one try. Okay. That's why in sports, they play the game. The underdog is never supposed to win, but the underdog does win. The underdog wins more in college basketball, in college football, and the NFL because they only have to win one game. In NBA basketball and in like a 7-game series, or the NHL and a 7, like you got to win 4 times to beat them, to win. Well, the underdog can still win, and sometimes they do, but out of a 7-game series, you got to win 4 of those 7. It's harder for the underdog to win that. It's not hard for the underdog to win 1 game. It's hard to win 4 out of the 7. So that's what the law of large numbers also tells us. Okay. Equally likely outcomes. No one result is expected to occur more frequently than another. The probability of an event when outcomes are equally likely. You take the number of outcomes favorable to event and divide by the total number of outcomes. It's very similar to relative frequency, except for the fact that we're not really counting here. Okay, we kind of have a total number, we kind of have a number, and we just divide those two, whereas the frequency, we are counting. We count up, and we figure that out. But it's very, very similar. Okay. Example in the equally likely method, when rolling a die, the probability of getting a number less than 3 is. What's the probability to get a number less than 3? Oops, sorry. Probability less than 3. So when you roll a die, how many outcomes are there? There's 6. Right? There's 6 things on a die. Well, how can you get a number less than 3? You can get a 1 or a 2. So you can get 2 things. So you have a 1/3 chance of that happening. Okay, so that's equally likely method. They are all equally likely to occur, right? 1, a 2, a 3, a 4, a 5, and a 6. They're all equally likely to occur. Okay. Statistical experiment, any activity that results in a definite outcome. All right. Sample space. We talk about sample space. That's everything that could possibly occur in an experiment. An experiment doesn't have to be something in science class where you're burning something, melting something, blowing something up. When we roll a die, that is an experiment for us in stats class. Okay? So rolling a die, tossing a coin, doing anything like that, a spinner, you know, the Wheel of Fortune, technically that's a sample space when they spin the wheel. I don't know if you've ever seen Wheel of Fortune or on The Price is Right when they spin the wheel. Those are all sample spaces. They have so many things that can happen. The sum of all the probabilities have to equal 1. So when you think of an event, the event rolling a die, everything has to add up to 1 when you put them all together. So when you roll a die, there are 6 outcomes. those probabilities have to add up. Those probabilities have to add up to 1. So 1/6 plus 1/6 plus 1/6 plus 1/6, 1/6, 1/6, 1/6 has to add up to 1, and it does. Okay. So let's look at a couple examples. Let's look at a couple examples here. Probability of an even number. Well, how many things could happen? Let's figure out our bottom first. Always want to do the bottom first so you know what to expect on the top, because the top can't be bigger than the bottom. Can't. It's impossible. So we're rolling a die. There's 6 things that can happen. How many even numbers are there? 2, 4, 6. So that's 3. So 3, 6, 1/2. We're not going to be required to simplify, reduce a fraction. We can just leave it as 3/6. Result, less than 4. So again, we're rolling a die. So I put 6 on the bottom. Okay. Less than 4. So 1, 2, 3. Oh, that's 3 out of 6 again. It's 1/2 in a different way. You can simplify it if you'd like, but you do not have to. Okay. And then of not getting a 2, well, we're rolling a die, so there's 6 things that could happen. How many ways can you not get a 2? 1, 3, 4, 5, 6. So that is 5. Sometimes we will get decimals, and sometimes we won't. It just depends. A lot of times we just leave it as a fraction and be done with it. Okay? Complement of an event. All right? The event not A, that's complement. You're complementing, you're doing the opposite. So we write this in a couple different ways. So not A can be the probability of A with a bar above it means not A, or A complement. Or we can write that as A with a little c. Okay. You can write it either way. Again, do you want to write the word complement out over and over and over again? You can. I'm not, but you might want to. But we can write it this way. So what's the probability of not A? Well, it's 1 minus the probability of A. Okay. Or the probability of A and the probability of not A equals 1. So what's the probability that you're going to work today? Okay. There's a certain probability that on a certain day that you work, and then there's a chance that you probably don't work on certain days. Okay, so there is a probability, if you have a job. If you don't have a job at all, well, then it's 0. But let's say you have a job, and certain days you work more often than others, just because of the schedule and everything. Maybe you work a lot of Fridays, Saturdays, and Sundays. Okay, so what's the probability that you're working? That has a number. Well, what's the probability you're not working? Well, it's got to be 1 minus that number that you're working, because you're either working or you're not. You can't be like, well, I'm kind of working. Well, I'm kind of not. No, you're either working or you're not. Whether you're doing a lot of work or not, well, that's a different question. But the definition of working, you're getting paid to be somewhere, to do something. Whether you're doing a lot of work or not, that's debatable. So these two have to add to 1. So the probability of A plus the probability of not A has to equal 1. And that's what this says down here. But we write it out all in symbols. They're putting the word not in there. I don't even want to write the word not over and over again. I'll just put a bar above it or write a C. Okay? Try to work less. All right? The probability you win versus the probability you don't win. When you say you don't win, that could include a tie for certain games, right? Some games can have a tie. So if a game can have a tie, you can't say it is win or lose. If tie, if there's a third option, then we can't think of it as a complement question. Okay. Okay. So just to see another example of that, if the probability that it will snow today is 30%. So if there's a chance it'll snow. It's not very likely, but there's a chance. So what's the probability that it's not going to snow? Well, we take 1 minus 0.3. And so there's a 70% chance that it's not going to snow. The probability of not snow. Again, writing it out with symbols. We're just learning it now, so it's written out in words. But eventually we want to transition to writing things with symbols because it's faster and easier. Okay? So 70% chance that it's not going to snow. Probability related to statistics. Probability makes statements about what will occur when samples are drawn from a known population. Okay, probability is what should happen. Doesn't always happen. Statistics describe how samples are to be obtained and how inferences are made about unknown populations. So probability is really based on what we know and what is supposed to happen. Statistics is analyzing things that we don't really always know, and we're trying to infer. Like, we may know about a small group of people, but we want to apply it to everybody. So that's what statistics is usually doing, and that's what we've kind of done up until this point. We've been taking a look at smaller groups and trying to apply it to everything. Now, we're taking what should happen and we're trying to apply it to maybe a specific situation. Okay. So that's the intro to probability. We're going to take a look at some basic probability questions next to try to get used to it. You have done probability before, but it has been a while. Typically, once you get to high school, there's not a lot of probability in the curriculum. A lot of probability is done in middle school, and then if you take prob stats, then we get back and hit it heavily. I think it's a very important thing to know the chances of certain things happening and to kind of give you an idea of certain things. An example, you're more likely to be struck by lightning than you are to win the lottery. That doesn't mean you can't win the lottery, and that doesn't mean you're going to be struck by lightning. But if we compare the odds of how many people win the lottery and how many people get struck by lightning, you're more likely to get struck by lightning. So just kind of put things into perspective there. Okay? Let me know if you have any questions.